Your Academic Skills Center presents this video series to help you strengthen your statistics skills.
Hello STAT students, and welcome to the video presentation for descriptive statistics. My name is Janine Allwright, and I am the instructional specialist at Walden's Academic Skills Center, where I lead the statistics tutoring team. In this video presentation, we will start with a quick reminder that we are still talking about the sample here to represent a greater population. We will start with the measures of central tendency, the mean, the median, and the mode, and we will discuss how to apply these measures to different kinds of variables. Then we will move on to the measures of dispersion, also called measures of variability. We will distinguish the application of the measures of variability between quantitative and qualitative variables, also known as categorical versus continuous. We will then move to SPSS, where I will briefly show you how to set up SPSS from mostly APA-generated output. And I will then run a couple of examples for a categorical and continuous variable and discuss the descriptive analysis in more detail with you. Lastly, I will show you how to save and export your work. We have a lot to unpack in this presentation, so let's get started. And here we are on the first slide that surely looks familiar to you by now, if you've watched the previous videos in this series. At this moment, we are still statistically describing sample variables. And in the last video, we looked solely at graphs, but in this presentation, we will add a statistical description to sample variables. Now, we are going to start with the measures of central tendency. That's the mean, the median, and the mode. A measure of central tendency really gives you that opportunity to deliver a summary of that variable, like what's happening with that variable on this data set. These measures are representations of where exactly most of that data is going to fall in a distribution. Where do they land? What is that central location? Usually the tendency of data is to cluster together, to cluster around the middle value, right? But we can also have situations of outliers on the left side and on the right side. It's not unusual to see some outlying behavior for data points. Now, the distribution of the scores, and for a continuous variable, what I mean by that is how does the curve look? That decides which measure you're going to report. Because for continuous variables, sometimes a mean has more value, and sometimes it has more value to talk about the median or the mode. And here you see the three measures of central tendency: the mean, the median, and the mode. We will not need to calculate these values, as SPSS, your new best friend, will calculate that for you, but it helps to understand how we get to that number. The mean is calculated by adding all the scores and dividing by total, and it tells you what the average is. The median is that exact halfway point where 50% of the participants score below the mean and the other 50% scores above the mean. And the mode is the number, the data score with the highest frequency. Now let's apply the three measures of central tendency to our levels of measurement. Remember, we have categorical variables that can be nominal or ordinal, and we have continuous variables that can be interval or ratio that SPSS calls scale. A nominal variable can be presented with the mode and only the mode. That just tells us which group in that variable, which level, exists of the largest population, the largest group size. An ordinal variable can be ranked and can be presented with the mode and the median. so we can see where that halfway mark is for those ranked levels in that variable. Scale variables deserve a bit of a more generous descriptive statistics here, and we can apply the mode and the median and the mean to these continuous variables. Now, I'm not quite sure if you noticed this here, but categorical variables cannot be presented with the mean, so careful there. When you run this in SPSS, don't click the mean for a categorical variable, as that produces a number that has no value, and you definitely don't want to show that on your output. Now, descriptive statistics is not just limited to talking about central tendency for variables. We will also want to address the measures of dispersion or the variability. And you can see 4 different kinds of measures of variability here on the screen. We can talk about the range for a continuous variable. That is just the distance between the minimum and the maximum. We can ask SPSS to produce the standard deviation as well. That shows us for a continuous variable how far the data is organized around the mean. Like on average, what is that distance on the left side and the right side around the mean? That tells us something about the variability there. The variance is another measure that SPSS can produce for us. It's nothing more than the standard deviation multiplied by itself, or standard deviation squared. That has no application for us in this video because it truly comes only into play when we compare 2 continuous variables for variability, and we're not engaging in that right now. And then there's the IQV that is only applicable for a qualitative variable, for a categorical variable, and that is short for index of qualitative variation. Now let's look at the levels of measurement again. I have them split up here between categorical, as you know, nominal and ordinal, and continuous, interval, and ratio, scale variables. Now for categorical variables, we have 2 options. We can look intuitively at the frequency distribution. We can run a little pie chart or a bar chart, and we can run a frequency table to see how the levels in that variable are distributed. We can also calculate the index of qualitative variation. I will present the formula for this measure on a next slide, but I'm not going to offer an example to calculate this because I feel that it's much more effective to intuitively evaluate the variability of a categorical variable. For the continuous variable, again, we can assess the range, the distance between the minimum and the maximum. We can look at the standard deviation and the variance. If we had more than 1 continuous variable, we can compare that. And we can look at the 68% rule. And that is a rule that we deduct from the histogram. Talking about histograms, let's look at the histograms for continuous variables. A histogram, in essence, can take on a lot of different shapes, but I have 3 examples here on the screen. It can be completely normal, symmetrical, that's the one in the middle, and in that completely normal distribution, the mean and the median and the mode would actually be the same. That's a good tip to remember, because when you look at your SPSS output for a descriptive statistic analysis for a continuous variable, take a look at the mean and the median and the mode. They will never be the same when you create that output file. There's always a little bit of a distribution that is away from normal, but it's a matter of how normal is our variable, right? As I wrote here at the bottom of the slide, it is an abstract experience to evaluate the normality of a histogram. On the left side, you see what a positive skew looks like. Something is pulling this graph to the right. There is an outlier maybe on the right side, and it's positively skewing this curve. At that moment, the mode is on the left side of the median, and the mean is moved to the right. It's that average is being pulled. A negative skew shows the opposite, where you can see that the mean scores below the median and the mode is at the end. Now let's imagine that you have a curve and that you ask SPSS to create a histogram, and you get a curve that looks for the most part normal, or as I call it, normal enough. When you have a curve that is normal enough, then you can apply the 68% rule, and it tells you a lot about the variability of the data. Because if you have a curve that looks, rather normally shaped, then you can conclude that 68% of the participants lies exactly one standard deviation away from the mean. 95% of the scores lies 2 standard deviations away from the mean, on the left side and the right side. And 99.7% lies 3 standard deviations away from the mean. Now I'm going to focus only on the 68% rule, and that is that darker area here on the curve. You will actually ask SPSS to calculate the mean and the standard deviation, so you can actually find that bracket, that dark blue bracket around the mean, where 68% of the scores land when you are dealing with a rather normal distribution. On the categorical side, as I mentioned, we have 2 methods really to evaluate variability. That's the IQV, the index of qualitative variation. But I always think that it makes more sense to intuitively approach this and figure out where the next person will land when you add an extra person to the data set for that variable. And I can show you how to interpret that with a pie and bar chart and a frequency table. Now, before we move to SPSS to work on an example, here is what I recommend when you run a descriptive analysis for a categorical variable. Build a frequency distribution. Select the appropriate measure, either the mode for a nominal variable or the mode and the median for an ordinal variable. Make a graph. We learned that skill set last week, and picture is worth 1,000 words. I think if you have a chance to show a graph in statistics, you should always take that opportunity. And we will focus, of course, on either a pie or a bar chart. And we will discuss the variability in that intuitive method. And I want to encourage you to describe your variable in words, right? What is the name of the variable? I mean, what is on the label in that data set? What are the levels in that variable? And we can look at that again to where you can locate that on the data set. And you really want to describe this variable in words. And of course, I'll briefly discuss the concept of social change. For the continuous variable, we're going to dig a little deeper. We're going to ask for the mean and the median and the mode. We'll ask for those measures of variability, the standard deviation, the minimum, the maximum, and the range. Of course, we'll make a histogram. And we'll talk about that variability in the context of a 68% rule. And this variable will also be described in words. And I will briefly talk about social change. Let's move our presentation to SPSS, where we can illustrate this rather theoretical explanation of descriptive statistics with some examples. Here is the SPSS dataset that I would like to work with. Now, this is the same dataset example as I used in the last video. And if you remember, we worked with 2 different variables on the categorical side, respondent sex and marital status. I find respondent sex a bit limited for this presentation. I want to show a variable that has more levels. So let's work with the marital status variable here. You see it here in this row. And just like last week, we're going to check that this truly is a nominal variable. This has 6 levels here. It runs all the way from married, group number 1, all the way through different levels to number 6, member of unmarried couple. And we're going to start with a frequency table, and I'm going to click on the Analyze button here. I'm going to use the Descriptive Statistics function, and I'm a big fan of the Frequencies tab here. In some videos and some books, you will learn about the descriptive function here as well, but when I use frequencies, I can apply that for both categorical and continuous variables. I'm going to click on frequencies. I ran some variables before, so I'm going to click a reset, and I'm going to find my marital status variable. There it is, and I'm going to bring that over. As I mentioned before, I like to drag and drop my variables to the right side, but you may very well use that arrow to bring your variables to the other side. Now, on the statistics end of this, I can see that this is a nominal variable, so the mean would definitely not be appropriate for any categorical variable. In this case, I can only click the mode, as the median is only appropriate for categorical variables of the ordinal level. This truly is all I can click here. So I'm going to click continue, and I'm going to mention something here. I'm going to leave the frequency tables here checked on the left bottom part of the setup screen. That is an option that is set by default for this frequencies option under the Analyze button. This is appropriate for a categorical variable, but later on when I'll show you the continuous variable, I'm going to unclick that option. I also would like to make a chart, and as you can see now, I have a chart option built in this setup, and for this has more than 4 levels. We'll work with the bar chart again, and I like asking SPSS to allow me to present this with percentages. I'm going to click continue and run this, and now I have the information that I need for this categorical variable. I can see that I have a little summary statistics table here. There are 1,991 participants on this data set that have volunteered their marital status, but 9 participants did not volunteer that information for whatever reason. You want to note that when you write up this variable. It's always important to keep an eye out for missing values. Oftentimes that tells you a lot. I've mentioned that example on the last video about the Afrobarometer data set, for instance, where African participants might be hesitant to talk about demographic variables, right? Now I can see that the mode is 1. That is the group with the highest frequency, and that is confirmed by looking at the frequency distribution here. Indeed, the married group is the group with the highest frequency. And I can actually also see what the percentages are for all those individual groups. And I can already get an idea of how variable the data is distributed here. At a glance, these percentages show me that there is a lack of variability. And I'll talk about that in just a moment. But I'm going to click inside the bar chart now and bring up the chart editor. And under the elements function, I'm going to ask SPSS to show the data labels. And since I asked for percentages, they are now placed in each individual bar. And at a glance, I have more viewpoint here on the group sizes and the heights of these bars, and they're easy to distinguish. Now, the more intuitive method that I promised to explain here to understand variability for this categorical variable really centers on one question, and that is what will happen when I add one additional person to this sample data set. Where do you think that person is most likely to land? And we can see here that the married group is by far the largest group, so it's reasonable to assume that an additional person will land in the same group. If this was evenly varied, if this was evenly distributed, you would expect that every bar would kind of be the same height, right? And that comes out to about 33, I would say, pardon me, 15 times 6, a little bit more than that, 16, 17% per group is what you would expect, but that's not what we're seeing here. The married group is the largest, then comes widowed, then comes divorced, and the other three groups are much smaller. So that tells you something about the variability. We certainly know that one extra person is going to land in that married group, so this is not uh, presented in an equal distribution. And now that we've talked about the frequency distribution and we've discussed the appropriate measure here, and we created the graph and discussed variability, I want to encourage you to really describe this variable with as many words as you need. Write a little paragraph, name this variable, share with the reader what the level of measurement is and why you made a bar chart, and then discuss that variability in that intuitive method. And then you can talk about social change as well. You can hypothesize who the stakeholders are for this information, who wants to know about the distribution of marital groups, marital status groups in the United States, and who benefits from knowing. Considering that this is a CDC data set, one could argue that there is some value for health reasons maybe, but that is for you to hypothesize about. Now that we've completed the descriptive statistics for our categorical variable, we can move on to the descriptive statistics for our continuous variable. I will use the same variable we used last week, and that is hours worked. How many hours per week do you work? Here it is. And as I noted last week, there is no information here under the values column, but we assess this as a truly scale variable. In essence, it's actually a ratio variable because there's an absolute 0 point, and every hour is exactly 1 hour away from the previous hour and 1 hour away from the next hour. We can click on Analyze here, use the same descriptive statistics function and the frequencies option. Let's click a reset here because we are going to engage in a different setup here. And here is the variable, how many hours. Sorry, did I miss it here? How many hours do you work? Here we are. Let's bring it over. I'm going to click on the statistics button. And I can engage in a lot more measures here for central tendency and for dispersion than I was able to for the categorical variable. I like to see the mean, the median, the mode, the standard deviation, the range, the minimum and the maximum. I'm not going to ask for the variance because, as I explained earlier, the variance only has value when I am comparing two continuous variables for dispersion, and we're not engaging in that here. The other two measures that I'm not going to ask for are the distribution, the skewness and kurtosis values. These are formulas that are being applied here, and we have not learned how to interpret these numbers, so we will evaluate the distribution in an intuitive way by reviewing the histogram. So click Continue. Let's ask for that histogram under the Charts option. Isn't it nice that this function is embedded here? We want to show our normal curve always on the histogram. And now let's go to this display frequency table button that I talked about earlier. I think it's best to unclick that because it serves no value for a continuous variable. It's merely going to show us all the possible hours worked. It will be a very big table without any value for interpretation. So I'm unclicking that for this variable. I'm going to click OK. And here is my descriptive statistics of our continuous variable. I have a really nice statistical summary box here, and I can see here that 510 participants told us how many hours they work per week. Surprisingly, 1,490 participants were shy to share that information. We don't know what the reason behind that is. This is an American data set, and we could hypothesize on that. In this setting, in the introduction courses here at Walden, we do not really engage with missing values, but it is something you want to note, because it's rather surprising that such a large group is not willing to talk about hours worked. Now let's continue. On average, the participant works 41.82 hours a week. 50% of the participants work less than the median, work less than 40 hours. 50% work more than 40 hours. And the number with the highest frequency is 40. That is the mode. Now we can see that the mode and the median are absolutely the same. And there's a slight deviation here with the mean, indicating that this is most likely a normally distributed variable, which is confirmed by the curve. We can see here that our curve is really stable. It has the same kind of tail on the left as it does on the right side. It is very nicely distributed, and that is good for us to know when we want to apply the 68% rule. Now, starting the discussion about variability, I can see that with the range being 88, this variable varies from 2 till 90. Yes, that is 90 hours per week. That's a whole lot of work hours. Now, since we have that normally distributed curve, let's move back to our PowerPoint and take another look at that variability of that continuous variable. And you may remember that I was pointing to that darker blue area that we're going to calculate. We need the standard deviation and the mean for that to find the edges of that blue area, where we know that 68% of our participants will score between those two values. I'm going to write here on my output file. That is not something I want you to engage with. That is just something I'm doing here for the sake of this presentation. But I know, based on the normal distribution, that 68% of our participants work between these two values, right? And the U minus the SD and the U added to the SD. That comes exactly to the values that I have calculated before, about 27, I'm rounding that up here, and 57. So 68% of our participants work between 27 and 57 hours. I also want to encourage you to write up the variable, the continuous variable in words, just like you did for the categorical variable. You want to describe this variable as much as you can verbally, right? You want to mention what the name of the variable is, talk about these missing values, describe that on average our participants work 41.82 hours, and so on. Social change-wise, this can have interesting information to share with stakeholders, right? There's already a question that we threw up, like why are so many Americans not comfortable with sharing their work hours here on a weekly basis? That is something to note. But we can also bring in the stakeholders again. Who would want to know about Americans' working behavior, and who could benefit from knowing? And that completes this part of our presentation, but I still owe you a couple of subjects here that I promised you earlier on, and that is how to set up SPSS for APA formatted output first. I've offered the summary for that process here on the slide. This is not just limited to version 27, but that happens to be the version that we're working with right now. I will show you how to find the menu option under Edit and use the Options button there to bring up the pivot tables and then select the correct table look. Let's get started with this. You would have to be in the data set for that because the options under edit do not appear under the output file. So I'm going back to the data set. I'm going to select under edit the options, the button here at the bottom. I want to make sure that I am in pivot tables, and under pivot tables I can select the correct table look, and you can see I've already selected that because my output is APA formatted for the most part. Once you've applied that, this works. I recommend doing this before you create output because it works forward in a sense. If you set it in this moment, then all your output from now on will be APA formatted. If you need more direction there, then I recommend to return to this video and review that portion again. Now we always want to save our output as well, so I'm going to go back to that output file. I'd like to save this in its current state. Save. We could call this descriptive statistics output. And I'm going to save that on my desktop for now. And so now this is safe. If anything happens with this in Word, when you're writing your assignment or your post, you can always call this sheet up. Right? But what I also want to do is at this moment, I don't need to copy this to Blackboard. And if you are stuck with that or you want to review that, I want to point you to the previous video that showed exactly how you can bring graphs to Blackboard. But I'm going to export this now to a Word document under the assumption that you want to use this to write an assignment. And I'm going to put my cursor on the white area outside of any columns or any boxes, and I'm going to click on the right button on my trackpad or your mouse, and I'm going to use the export function. If you cannot locate that or the mouse is giving you trouble, you can also locate that by using the file command and use the export there. And under that export command, I would like to have this exported as a Word document, which it is already set by default here, but change that. If you've been working with graphs last week and you're moving to Word this week, you have to manually change that. And I want to click my Browse button here and give this a name. This is my descriptive output, descriptive statistics, or descriptives in Word. And now this has become a Word document. I have to click OK to make that happen. And you can then call that Word document up in your MS Word and either write your paper inside that document or bring the material over copy paste to your preferred formatted, APA formatted Word template for your paper. And if you want to review these options here on the PowerPoint, I have listed them here on this slide. As I mentioned, if you want to review how to place the graphs on Blackboard, then please return to last week's video. And this completes our visual displays of data presentation.
Thank you for watching this video presentation. If you have course-level statistics questions, reach out to our stats tutors at statsupport@mail.waldenu.edu or view our statistics support resources at academicskills.waldenu.edu.